Estamos ao vivo, então, aqui de novo, da Jabro, aqui em Ribeirão Preto. E hoje, agora, esse podcast é muito especial, porque vai ser o primeiro podcast internacional da radiologia. Hoje a gente está recebendo aqui o professor Ruben Pawels, que palestrou ontem aqui na Jabro para falar sobre inteligência artificial. A gente vai falar um pouquinho mais sobre isso, mas é muito importante avisar para você que está aí acompanhando a gente que eu vou fazer as apresentações aqui de todo mundo em português e depois nós vamos continuar em inglês, tá? Então, talvez a gente consiga aí ativar a tradução ao vivo. A gente não sabe se isso vai funcionar, você pode tentar. Mas, em breve, quando tiver aí disponível essa live no YouTube, você vai poder ativar aí a tradução sem problema nenhum. Então, nós estamos com uma mesa hoje aqui de peso. Nós temos aqui ao meu lado o Luiz, que é vice-presidente da RadioMemory. Ele é o diretor de inovações e também o desenvolvedor do nosso sistema de inteligência artificial. Nós temos aqui na minha frente o André, que é o nosso diretor de desenvolvimento. E aqui no cantinho aqui da mesa, o nosso convidado de hoje, que é o Ruben Pawels, que é mestre em imaginologia, doutor em ciências biomédicas. Ele estudou em Leuven, na Bélgica, e se tornou pesquisador de pós-doutorado. Foi professor na Chulalongkorn. Okay, thank you very much. This is a very hard name to say. Em Bangkok, na Tailândia. Foi pesquisador e visitante na USP aqui em São Paulo. E o Dr. Ruben também foi bolsista Marie Curie no Instituto de Estudos Avançados de Aarhus, na Dinamarca. E hoje é atualmente professor associado do Departamento de Odontologia e Saúde Bucal. Where you teach with Rubens. He was with us yesterday here. It was incredible. He's a very nice person. He's so kind, and he's an incredible dentist and radiologist. I admire him so much, and I am very happy to have you here today. I saw your lecture yesterday. It was brilliant, and I believe that we have to talk more about AI, because we are in this reality now, and I believe that almost every equipment in our market now has AI, and we radiologists, we don't actually know how it works. So you know a lot about AI. We were talking before here because Luis has so many questions. And we are going to keep more generic in the questions here today, because the point here is to enlighten our radiologists about AI. But I believe that you can search for his materials and presentations. And yesterday was like, I was exiting the room and everybody was, oh my God, now I know what is AI. That's incredible. Because we have AI, it's a reality outside of radiology and odontology. We have ChatGPT, and we have AI in many apps that we use today in social media, but we don't actually know how it works. We just use it. And it's so important to know how it works. It's something that I love here, because I work with AI in RadioMemory. I have I am a happy radiologist to work with this here. And I think it's beautiful to see the things happening when we make the notes, and then it goes to the developers, and when it come back to us, we see, oh my God, he learned. It's doing by itself. It's incredible. So thank you for accepting to be with us here, Ruben. And
before you start the first question, I would like to say that knowing is a crucial step to trust. So for the radiologists to trust the technology, it's very important that they know that's not magic. It's not something. It's not something thin. It's not something that's done without very much work and statistical information and it's a very cool technology. It gives fantastic results, but it's very well grounded in science and statistics, and it works very well. And learning about it is a crucial step to trusting it.
That's perfect. Yes. So yesterday you were talking about explainable AI and generative AI, and when we were talking, you said it will be hard to say in a podcast to explain generative AI in the podcast. So I would like to know more about explainable AI and what exactly is explainable AI and why it's a crucial aspect of AI development, and what is explainable AI in radiology, in odontology?
Sure. Well, first of all, thank you so much for having me. Very glad to be here, and I couldn't have said it any better. Your introduction was absolutely on point. Regarding explainable AI, this is a bit more of a recent concept that followed all of the development that came before. If you go back about 10 years, when deep learning really took steam because of new algorithms being introduced, because of computational power increasing, we had a few years of heavy development of mostly neural networks, and for images mostly kind of convolutional neural networks. Deep learning became, for me, the hottest topic I've ever seen, experienced in research. But at some point we noticed that disregarding all of the positive aspects, the high performance of these models, all of the flexibility you can do with it, there's now a bit of a new problem. The fact that these models are, as such, quite complex and have up to millions, sometimes billions of parameters, it can sometimes be hard to understand what happens between a given input, like an image, and a given output, like a diagnosis, a segmentation, anything else that an AI does. Because everything in between, it's not quite a black box, because you know exactly, you can see the value for each parameter as long as you have trained the model yourself. You know what it consists of, but you cannot really understand it, what the reasoning or the intelligence part of the AI. So, whenever AI then is used for rather important decisions or important applications, it would be nice to get more information about what's happening, what is leading to a certain output. And of course in medicine we are dealing with very important applications that can directly affect a patient's well-being. But you have other facets of society and industry, like the financial world. They also look at explainable AI because they are using AI to detect fraud and to detect wrong transaction or bad transactions. But then the bank, the institution has to be able to explain to the customer or the business why they think it is fraudulent. So they also went now to explainable AI. So to conclude, as a concept, it is a way to decompose an answer or an output of an AI and to get more information that can help you as a user judge the performance and the confidence in that performance and whether it should be followed or overruled.
That's perfect.
Just to the viewers, to the listeners, maybe it's a simple analogy would be you turn yes and no into why it's yes and no.
Yeah.
So it's a way to trust it more.
Yeah. You gave us an example yesterday, and it was very simple to understand this. It's like the input is an image you put to know if the image has a lesion or no, has an anomaly. And you know the output is yes, there is an anomaly, or no, there is not an anomaly. But why? How? It could get to yes or no. That's what we have to understand. That's what is explainable AI.
Yeah. Yesterday in my lecture I defined a couple of levels of explainable AI. I'm not aware of any kind of official level, so this was my definition. And at a very base level, an AI would tell you will give you a binary response. If it's a classification task, you get a 1 or a 0, a yes or a no. I put that at level 0 in my classification because that's even below the minimum that I think an AI could give you. Because at the very minimum it should give you a probability, not a binary response. But then you can go further and you can, I defined the what, so not just saying this is okay, this is not okay, but specifying what is not okay. Then at the next level I defined the where, showing, in the case of images, showing the user where it thinks the problem is by using some kind of hotspots or heat map, any kind of way to visualize it. And then at the possible next value you have the why, where it tells you, okay, I think this is the issue and I think these are the features, the components that lead me to believe that. So that's another level of explainable AI where I think we haven't quite reached yet at this point.
Yes.
I would like to add that the explainable AI is very important for the user to know what's happening, but it's crucial for the developers to fine-tune the models so that the developers don't know either what's happening. So if you can identify what's happening at each stage of the decision process, we can attack the problems, we can try to fine-tune the models. So it's very important for the development process also.
Absolutely, it's beneficial for both sides. Yeah. Well put.
From a developer point of view, could you think of it like a logging? For example, like a logging of the prediction?
Not sure what the logging
the steps. You're seeing this feature was extracted and then we this was refined to this and the steps involved in reaching the decision.
Sure, yeah, I think so. You can consider it as a multi-output becoming a single output. So I don't know how to define it, if you have to define it technically, but indeed there's a stepwise progression where first you get the components of a final output and then it is combined either just in a very basic way or with a second kind of network into a final prediction. So yeah, absolutely, it's a logical conclusion of steps.
Perfect. I also would like to talk about something you said yesterday about the levels. And you said it's not important to know what anomaly we are dealing with, but it's important to know, is there an anomaly or is there not? Where is this? So maybe people can think that we are searching for the specific anomaly. And you said yesterday, it's more important to know if there's an anomaly. And if you have to make a biopsy. And so, do you believe we will have in the future a possibility of knowing what anomaly is this, and is the market concerned about knowing what is the anomaly, or are we going to stay in like there is an anomaly and you have to do something about it?
Sure. So I made this point yesterday specifically when talking about tumors and cysts and that kind of lesions. So, and I showed an overview, kind of a table or a figure with all types of odontogenic cysts and tumors defined by the WHO. And I didn't count them, but there were a lot. And some of them, even though I'm not a radiologist, I've been in the world for some time and I hadn't heard of some of them. So I assume they're very rare. And that led me to say that it's very unlikely to be able to train an AI for each of those dozens of, in this case, tumors and cysts, but you can expand that principle to other types of lesions and pathology. But it might be possible then to describe features and then use those features to make some kind of differential diagnosis, option one, or forget about the diagnosis, at least the AI diagnosis, but just make a decision, should this patient get a biopsy or not? Because typically in a clinic I believe that would be a major decision to make to distinguish already kind of benign lesions or lesions that can be treated without needing further information, and the other ones that really need a final conclusive diagnosis, typically using a biopsy.
Yes, because the more important is knowing how to proceed with that you are seeing. So we help more the dentist by telling him what he has to do after the image exam. Okay.
I would like to add a little bit. I think the decision process should be. I think the fear of AI. That's a important topic to discuss. The fear of AI substituting the work of the professional is it's not a well-grounded fear, at least not for now, because of this, the objective of the AI tools is not to reach the perfect diagnostic. It's there to assist in the description of the image, into the features necessary to reach a good and a more reliable diagnostic. So I think that's the aim. That's the aim of the AI research we do, and everyone asks, does it find the anomaly? Does it find the pathology? Does it make the diagnostic for me? It's probabilistic, so it never can be trusted as a certified professional, at least not for many years. And so the aim is not to find the exact answer, but to help the professional to reach the most reliable answer.
May I comment on this?
Yes.
Yes, I want to know your opinion
Sure.
about this.
Well, I fully agree with your sentiments, and I think most people would agree. If you go back 4 or 5 years when AI was really coming up, you could see immediately a reaction from, let's say, the radiological corner. You had societies publishing statements and expressing their concern about the future of the profession. And like I said, I fully agree with the statement that AI is really intended as an help, a tool that helps the clinical expert. But sometimes I think, and I make sometimes the analogy with self-driving cars. I mean, you can find other examples. What if we reach a point, or when we reach a point, that AI on average outperforms a radiologist? And we can kind of see it for very specific tasks already. Some research showing that, okay, a radiologist has a somewhat lower diagnostic efficacy than a certain AI for a very specific task, for a specific data set. But once we get to a point where an AI has been proven to outperform all but the best radiologist, what is then in the patient's best interest? Should we then keep decisions in human hands because we are more comfortable with that? Or are we then making a disadvantage to the patient because we have the research backing up the fact that AI, but you, as you mentioned, that we are talking about years in the future, probably.
Yes. We will have time to adapt.
Sure,
and
that's it.
I think explainable AI will have a very important role in reaching this point, because even if it outperforms, if it can't explain what's happening, nobody's going to trust it. Mm-hmm. So I think we have to go and develop all these areas first, but it's the future. So everyone, we can focus in more important human tasks and let the AI do the statistical work.
Mm-hmm. And to finish the analogy with, or to make the analogy with the self-driving cars that I mentioned, we can see that, in many ways they're already driving safer than most humans, but in certain conditions at least, and depending on what we're talking about. But whenever there's an accident, like there have been a few, it's back to the drawing board.
Yes.
And they are really considering all of the possible reasons for the accident. I think AI implementation is going to be similar. Like if and when something goes wrong, it will be scrutinized and things will really kind of go. It's not really a step back, but definitely it will be on hold a little bit, and things will be really, like I said, scrutinized. So
the bar is going to be higher for AI.
That's it.
Yes, much higher.
Yeah.
Basically, the AI won't make us slaves like many people
No,
say.
that we can't say because we're talking about AGI and other subjects. It's not this kind of assistant.
Yeah.
Who knows?
Yeah.
GPT is here. I really don't know what's going to happen in the next 10 years.
I am looking forward to know this. So we are talking about AI and explainable AI. I want to know what we have here in the moment in dentistry. Can you give me some examples?
Sure. I feel like we actually, it's not that complicated to implement it. And in a way, we collectively already have everything available to make it more explainable. Because I feel in most situations, specifically to radiology, showing a heat map or something that shows where the AI thinks the problem is, can already be sufficient. The other part I mentioned that we talked about is just another level. But if you have probabilities of a confidence probability or something like that, you have something visually, which any deep learning model, it already has that information. You just need to get it out of there and show it on an image. There's no extra effort needed, no extra development needed to have information in which pixel, which voxel or something. There's more important information than in others. So I feel like we have had some tools, I guess also commercial tools nowadays, that simply have either the original image, radiograph, anything, photograph like that, and then the same one through the eyes of the AI that shows, first of all, the final output, but also some kind of color coding, some kind of, like I said, heat map that pinpoints where it is. And I think that can be a super useful tool to the radiologist to go beyond just that one number, like the 80% confidence, and seeing, okay, where is it? And if it's in the wrong place, then that confidence doesn't mean much because it's just having some kind of false positive pixels included. So I feel like the concept is not that hard. It's not that hard to implement, and I think it makes enough sense that I will believe that most researchers and companies will in fact go that route, because I feel also that like the end user, the radiologist or clinician, would really like to see that. So it makes perfect sense to go that way.
Yeah.
I would like to add that it not only makes sense, but it's the partial step to reach the final decision. So when the model is not yet fine-tuned enough, what you have is a probability cloud, a map of what's happening. You have to analyze it to make your model better. So you can just show this for the user. So it's perfect.
Yes. Okay. I know that's hard to explain about generative AI in a podcast, but yesterday I was quite amazed with your explanation about generative AI, and I think if you can explain briefly for us what is generative AI, please.
Sure. Well, luckily it's made a lot easier by the fact that in the last couple of months, generative AI came up almost in an unforeseen way, and that we have it now, well, in the hands of everyone, from the smallest child to different kind of professional people or just people using it for fun, students and all. They're all using some type of generative AI, and then we're mostly talking about text generation. And the concept really applies to any kind of data generation. So yesterday I focused on creating synthetic images, which is just one example of generative AI. So the overall concept would be to generate synthetic, fake data that is realistic. And I put realistic between apostrophes, because what realistic means depends on the kind of data that you want to generate. So if you want to generate radiographs, it has to be something that looks like a clinical radiograph. If you want to generate a painting, then it has to be something that looks like a painting. So the word realistic doesn't always mean photorealistic, realistic as we think it is. It is just the data that it is supposed to represent. So that would be, in a nutshell, what generative AI is about.
Perfect. You showed us some images you tried to do with radiology, and you didn't have success on getting those images. It was amazing. The bite wing one was incredible. Okay, the people won't see the images, but basically, nowadays, it's not, you cannot create radiology images with reality images. Like, it's not images that you see and you say, okay, it could be a real image of a real patient, because you see that the radiographs are not realistic. But do you think we are going to achieve this in some point?
So the example I showed yesterday, like the bite wing and the other ones, they were all examples from, let's say, generic image generation models. And in fact, even though we cannot show it now, anyone listening can try this out for themselves, because you have tools online where you can just enter text and you get something back. And I feel like many listeners will have already
something like
played
Mid-Journey or...
Certainly, I will try. Yes.
Yeah, the ones I showed yesterday, one of them was from DALL-E 2 from OpenAI, same company as ChatGPT. And the other one is from a model called Stable Diffusion, which is an open model that anyone can use, and they also have the code available so you can train your own. The ones I showed were trained on very large data sets of, let's say, images with corresponding text, but any type of image. So I showed example of cats, I showed example of other things. And well, what you'd get with these kind of models are typically very, what I call cool images, but something is off, especially when you want to get something realistic that you cannot distinguish from reality. They're great at creating artistic interpretations, but in terms of realism, it's not quite there yet, because maybe, well, we need more time, or maybe we need to develop a more custom model for a very specific type of data. So to answer the question, can we reach the point of generating realistic radiographs? I feel like we can, at least something very close to it. But we would have to essentially train these models ourselves. So we take, for example, the Stable Diffusion architecture, but now we train it, or retrain, but maybe, let's say, we train it from scratch on a large set of clinical radiographs. And then I feel like we will get something much closer to reality than what we saw yesterday.
Yeah.
I'm not sure how close. It's something that hasn't quite been studied a lot yet. But seeing that we can already do this for partial images, like in CT, we can use it to in-paint certain regions, I would say why not just generate an entire image from scratch. So I feel like we could go there. There's definitely some effort needed, and you will have to start from a rather large data set, so we may have to join efforts with different centers or institutions, but I feel like there's definitely a road to getting there.
Great.
More interesting than just talking about the concept of generating these images is why we would generate these images. I think I would like you to elaborate on why would we use synthetic images in any way. I think that's very interesting.
Yeah, for sure. I was thinking about it in two different ways. I focused mostly on generating images to then use for further AI training for, let's say, diagnostic tasks, segmentation tasks. This would overcome a lot of limitations and issues that we find nowadays. And in some ways we have reached a saturation point in research where people are training decent models on data from their clinic, but they are limited in, first of all, the sample size by the patients that they have in their database. They're limited by ethical issues, so you cannot really easily work together with other centers because it's hard to transfer data.
GDPR,
that's
LGBT.
Exactly. So that's one kind of way to overcome that, by at least augmenting what you have with synthetic data. And you can find some examples, maybe not from medicine, but other types of applications where a 50-50 mix between real and synthetic data can really improve the performance of a model then trained on that data. But I think there's other benefits. Let's say student training or radiologist training. This is also limited sometimes by the patients or the data that you happen to have available. And now that we're going more into personalized training and personalized education and all that, it would be nice to be able to generate on the fly, quasi-infinitely an image with a certain type of lesion, a certain type of problem, which is then already kind of pre-labeled because it is generated, so you already know where the problem is.
And you don't have the data problem.
No data problem. Every image is new and unique, so there's a lot of benefits also for human training and for AI training. I think that's kind of the two applications that I was thinking of.
Great. You answered my next question right now. So, we talked about a lot of things today, and I don't have many questions to do now. If you wanna.
No, I have some questions. One of
million questions.
Yeah, I have lots of specific questions. I already talked a lot with Dr. Paul before the podcast, and I'm probably going to talk a little bit more after. But I think for the podcast, I think we could reinforce. We could do a little bit more on what's the implications of AI in the near future, and a little bit more. What do we have to do to teach the community, the practitioners? What can they expect? What's the directions that the researchers and the developers should go to make it work with trust, with reliability? What's your take on where do we go from here?
Sure. I will go back to the very start of the podcast. Kind of the first statement you made is to show the practitioners that it's not quite magic. There's a lot of very nice and complicated mathematics underlying it, but you can explain the basic principles in a pretty palatable way. And I tried to do this in my introduction to my presentation yesterday. I talked 15 minutes, 20 minutes about supervised machine learning, and I call it 101. No prerequisites, no mathematics needed. I explained using a very simple curve how things like gradient descent and other concepts used in machine learning, how that works. I used an analogy like going down from a mountain, and this is the type of material that I will also teach to undergraduate students that now hear about AI for the first time. So you can give that information to any kind of level of profession, any kind of background, in a way that they can understand. Okay, this is more or less what's happening. There's a lot more, behind that, but at least it's not something magical, and there's actually a very deterministic aspect to it. You will always, for a trained model at least, you will always get the same output for a given input once it's trained and if it's fixed. So things like that. Since this topic came up rather quickly, in a matter of, let's say, 10 years, it went from almost zero to where we are today. Teaching is lagging a little bit behind. So we can see now that slowly but surely courses and things like that are being implemented in curricula, undergraduate curricula in medicine and dentistry, definitely specialization courses, CE courses and all that. So definitely there's some work to be done or some effort to be done there, but I feel like it will be possible to teach them to an extent that they will be very confident in at least a principle. And then for any given tool that they use, it's up to them to understand as much as possible how it works and how they can use it in the best way.
I think one important aspect of what you're saying and what we should teach the community at large, the radiology community, is to look for the explanation, look for the steps, look for not trying to find the answer, but trying to find the rationale to get to the answer. So, like you said, let's show the features. Let's show where we think there's an anomaly. Let's show why we are showing you in the probability of this. Let's help you find the differential diagnostic and not try to do the work for you. I think good AI, at least in the current stage, is the AI that can augment the power, the diagnostic power of the professional, and not trying to substitute it. I remember software, I think 7 years ago, medical imaging software tried to find mammography lesions automatically, and it tanked, it bombed, because it find a lot of artifacts as lesions, and if you go down the probability, then it wouldn't find anything. So it got in the way of the practitioners much more than helping them. So I think the goal here is to try to strive for the explainable, for the features, for the path that you have to take. So I think it's a human aspect of the industry, and I love that your research and your position is on this objective, on this goal. Would you care to elaborate a little more about this?
Sure. Well, I do fully agree, and on top of that, I would say that there can also be some responsibility to, let's say, the developers. Once we're talking about commercial tools, I think that within the limits of intellectual property, it would be nice for the developers to explain to their users how the tool works, either before, like as a sales pitch, or after sale to help them use it and all that. So, yeah, I think I don't have too much to add other than that. So it's all about helping the user just understand within the limits of, because we cannot go too deep into what is behind it. Like yesterday, that I showed a slide with two types of training the users. One type would be to talk about things like Wasserstein guns and all that, and very complicated topics, or maybe not even that complicated, but just stuff that takes time to explain, or to give it to them in a way that any clinician will understand. What data was it trained on? If we think about radiology, is it going to be applicable, or what we call generalizable, to images from their machine? If it's trained on images from a different machine, from a different vendor, that can be an issue. What was the performance of the model, not during training, but during testing on new data? If it makes errors, what are the main causes for errors? Like you said, artifacts and all that. So when should a user be more mindful of the AI? When there are visible artifacts or high noise and all that. So these are all things that you can explain in a very easy way to the user, and then they can just apply it like that. There's no learning curve needed in that case.
Very good. I would like to expand on a little detail that you mentioned that I find it very, very important, is that the AI is not perfect. It's a probability. So I think that's a very important point that the vendors have to teach the customers. It's not here to take your place. It's here to assist, and you have to take it with a grain of salt. So you have to understand that it's a suggestion, and the vendors have to try to explain. That's why explaining is so important. You have to try to explain the best way you can, so that the practitioner can make a educated diagnostic using all the tools available. So that's very, very the error rate and the probability of getting it right or not. I think it's the main part, and it has to be because the vendors will say, mine's better, mine has a much better. No, it's practically magic, and you can't do this. You have to explain the professional that it's not magic, and it will get it wrong. So you have to pay attention, use it as it is.
And we are improving.
Yes.
Every day.
We're improving every day.
Guys, we are running out of time, so we have to be very quick now.
Okay. Let me just make one more specific question that I talked to Dr. Pawels before the podcast, and I find it very interesting. One of the uses of generative AI for imaging purposes, that's very important for radiology community, is to try to denoise the images and try to take from the images artifacts and information that's there because of the limitations of the method. So in a CT scan, the metal fillings, they generate reflections and they wreck the image, and they make it very hard to perform the diagnostics, and AI can help a lot in cleaning this image, and not also in cleaning but in augmenting the resolution of the image and generating more beautiful images.
Sharpness in the image.
But what are the ethical and technical limitations of these applications? I think that's very interesting because lots of vendors already have some kind of image augmentation in place. But what are the caveats of using this in this manner?
Sure. I showed some examples yesterday of all of the things you mentioned. So denoising and what we call super resolution, which is kind of the opposite principle. So denoising would be a way to get rid of the noise while maintaining the sharpness. And super resolution would kind of be the opposite of boosting the sharpness while keeping the noise reasonable. And I also showed a couple of examples of artifact reduction in painting and things like that. And indeed, in research at least, we can see that the resulting images look nice according to metrics that we can use. Quantitative metrics, they are better to what we consider a reference image. But it is a very valid question to ask, are they in fact diagnostically better? Unfortunately, most research stops before that point, because that's kind of a next level of study where you cannot even do a subjective interpretation by radiologists. No, you actually have to look at, does lesion detection improve when you apply these image enhancement techniques? I am personally more skeptical because I have somewhat of a background in medical physics, so I'm in touch with both, let's say, the hardware side of imaging and the software side, what comes next. And it's a bit hard for me to believe that you can really overcome physics and hardware limitations, things like a focal spot, like a detector pixel size. These are parameters that are fixed, and as long as those are limiting your initial image quality, I believe there's only so much you can improve. What you want to get now out of it is already lost from the start. But I'm open-minded, I have to be as a researcher, so I would like to see if indeed maybe it can just augment, it can boost something that was in the image but that is just almost imperceptible, so it can reach a little bit of a higher quality level, but it's definitely not going to be magic like we used to use the word magic before. If it's trying to fill in a complete gap in a scan that was covered in artifacts, it's very unlikely that what it's filling in was really there for that patient. It's filling in what it thinks is a regular anatomy. If there happened to be a lesion there, it's probably not going to appear. So I think a caveat is the right word. We have to be very cautious about using it. We need to validate them at a higher diagnostic level before we can claim any type of benefit. But that story is not that different from pre-AI world, like metal artifact reduction that we already have in CT for years, if not decades. Similar story. We are painting in data, we are doing interpolation. It's very questionable if that really gives you a better functional diagnostic image.
Cool.
Great.
Very
So
good.
since we are enthusiasts of radiology and technology and AI, we could be all day long here talking about these topics with you, but we have to close this. Our staff is like, okay.
Too much time.
Okay. So thank you very much for accepting our invite to be here. I believe it's very important for our community to have you here talking about this and a topic that we don't have many people talking about. So thank you very much for accepting, and I am very honored to be here in this table with you and with you both. You are inspirations for me, and thank you Radio Memory as well to have me here and and to give me the opportunity of working with AI. I feel very honored to be here working with this and working with Luis and Fabio, who I consider great scientists and developers.
I would like to also thank everyone, and especially Dr. Paul. It's very nice to have someone with so much research in an area that we are breathing and eating for the last 5 years.
Yes.
So it's very, very relatable, and it's very interesting to hear about other aspects, because we developers, we have a very technical view, and we are very in touch with the market, so we have a little bit of experience about the fears and what kind of education we have to perform. But you brought lots of human aspects and technical also that are very important, and it was very I'm very enriched by the talk and by your presence here. I would like to thank you very much.
Thank you so much. It was an absolute
And we also have to give you a gift.
Oh.
Yes. So thank you. It's a little gift from the state of Radio Memory, and you will have here some things to eat from Minas Gerais,
We have a very good cheese.
Yes, which is the state with the best food in Brazil.
and the best cachaça.
In the best
Best cachaça.
cachaça. And you have cachaça.
Yeah, that's
Yes.
a present.
Okay, thank you one more time very much. I'm so sorry for my English.
No,
I
it's
believe
very
there are
good.
many wrong words, but we made it.
Yes.
We made it. We are. Congratulations for us all. Thank you very much. And okay, we can finish now. Pessoal, fica aqui. A gente vai ter vários outros podcasts acontecendo hoje. Muita gente legal vai passar por aqui. Muitas empresas também. Então, fiquem com a gente aí no YouTube ao vivo. Ok.